On September 10th, 2025, NASA announced a discovery that could reshape our understanding of Mars and its potential to have once harbored life. The Perseverance rover, tirelessly exploring the Jezero crater since its landing in February 2021, uncovered a rock sample named Chayava Falls that contains organic compounds and other intriguing features suggestive of ancient microbial life. This finding, detailed in a special edition of NASA's Mars Report and discussed in a media briefing on September 10th through 12th, marks a pivotal moment in the search for extraterrestrial life. Described as the rover's most puzzling and potentially important sample yet, Chayava Falls has ignited excitement among scientists and space enthusiasts alike. Below, we delve into the discovery, its implications, the science behind it, and the path forward for Mars exploration. The discovery, Chayava Falls, and its significance. The rock sample, collected from the northern edge of Jezero crater in July 2024, was retrieved from a site believed to be an ancient riverbed, a location where water once flowed billions of years ago. Named Chayava Falls after a waterfall in Arizona's Grand Canyon, the sample is a conglomerate rock, rich in diverse minerals and textures that tell a story of Mars' watery past. What makes this find extraordinary is the presence of organic compounds, carbon-based molecules that are the building blocks of life as we know it. During the September 10th media briefing, NASA scientists, including project scientist Dr. Kenneth Farley, revealed that Chayava Falls contains chemical signatures and structures that could have been formed by microbial life billions of years ago. The sample features microscopic spots with distinct chemical compositions, resembling patterns seen in Earth's fossilized microbial mats. These spots, described as leopard-like in appearance, are surrounded by calcium sulfate veins, suggesting water activity that could have supported life. Additionally, the rock contains iron and phosphate, minerals often associated with biological processes on Earth. This is the most compelling evidence we've seen yet for the possibility of ancient life on Mars, Farley noted, though he cautioned that the findings are not conclusive proof. These signatures could also result from abiotic processes, but the combination of organic compounds, mineral patterns, and evidence of past water makes this sample a top priority for further study. The science behind the find, Perseverance's discovery, is a testament to the rover's advanced scientific toolkit. The sample was analyzed using the rover's SHERLOC instrument, scanning habitable environments with Raman and luminescence for organics and chemicals which detected the organic molecules. SHERLOC's laser-based spectroscopy identified carbon-based compounds, while the PIXL, planetary instrument for X-ray lithochemistry, instrument mapped the rock's mineral structure, revealing the calcium sulfate veins and iron phosphate spots. These features suggest a complex history of water interaction, potentially creating habitable conditions in Mars' distant past. Jezero crater, the rover's exploration site, was chosen for its geological significance. Billions of years ago, it hosted a lake and a river delta, environments conducive to preserving signs of life. The Chayava Falls rock likely formed in this delta, where sediments carried by flowing water settled and hardened over time. The presence of organic compounds in such a context is significant because, on Earth, similar environments, like riverbeds and lakebeds, often preserve fossils of ancient microbes. However, scientists remain cautious. Organic molecules can form through non-biological processes, such as volcanic activity or chemical reactions driven by solar radiation. The leopard-like spots could also result from mineral precipitation rather than microbial activity. To distinguish between these possibilities, the sample must be returned to Earth for detailed analysis in advanced laboratories, a key goal of NASA's Mars Sample Return Mission. The Mars Sample Return Mission, the next step. The Chayava Falls sample is now sealed in one of Perseverance's titanium tubes, stored for eventual retrieval by the MSR mission, a collaborative effort between NASA and the European Space Agency ESA. The MSR mission aims to bring back a cache of Martian samples by the early 2030s, allowing scientists to study them with instruments far more powerful than those aboard the rover. These include mass spectrometers and electron microscopes, capable of detecting molecular fossils or other definitive biosignatures. The MSR mission, however, faces significant challenges. Estimated to cost over $11 billion, it has drawn scrutiny for its complexity and budget overruns. The mission involves launching a retrieval spacecraft, landing it on Mars, collecting the samples left by Perseverance, and returning them to Earth, a feat never before accomplished. Recent safety panel reviews have also raised concerns about delays in the Artemis program, which shares some technological dependencies with MSR. Despite these hurdles, the Chayava Falls discovery underscores the mission's importance. This sample could be the key to answering whether life ever existed on Mars, said NASA Administrator Bill Nelson during the briefing. Implications for astrobiology and beyond. The discovery of Chayava Falls has profound implications for astrobiology, the study of life in the universe. If the organic compounds and structures in the sample are confirmed to be of biological origin, it would mark the first evidence of extraterrestrial life, fundamentally altering our understanding of biology's prevalence in the cosmos. Even if the signatures prove abiotic, the sample offers critical insights into Mars' geological and chemical history, shedding light on how planets evolve and whether they can sustain habitable conditions. This find also fuels excitement for future Mars exploration. NASA's Artemis program, which aims to return humans to the Moon as a stepping stone for Mars, could benefit from the renewed interest in Martian science. The data from Perseverance informs where future crewed missions might land and what resources, like water trapped in minerals, could support human exploration. Beyond Mars, the discovery resonates with exoplanet research. With over 6,000 exoplanets now confirmed, a milestone announced on September 17, 2025, scientists are eager to identify worlds with conditions similar to ancient Mars. The James Webb Space Telescope, JWST, and upcoming observatories like the Vera C. Rubin Observatory will build on these findings, searching for biosignatures in distant atmospheres. Challenges and skepticism. While the Chayava Falls discovery is thrilling, scientists urge caution. The history of Mars exploration is filled with tantalizing hints of life that later proved inconclusive. In the 1970s, the Viking landers detected chemical activity in Martian soil that some initially interpreted as biological, but later analyses pointed to abiotic causes, such as reactions involving perchlorates. Similarly, methane spikes detected by the Curiosity rover have sparked debate, with explanations ranging from microbial activity to geological processes. The Chayava Falls sample's organic compounds and structures are promising, but only Earth-based analysis can confirm their origin. "We need to rule out every non-biological explanation," said Dr. Amy Williams, an astrobiologist on the Perseverance team. That's why the sample return mission is so critical. Public and scientific enthusiasm is tempered by logistical challenges. The MSR mission's timeline means definitive answers may be a decade away. Budget constraints and competing priorities, such as Artemis and climate research, could further delay progress. Additionally, some researchers argue that Perseverance should explore other regions of Jezero Crater to diversify the sample cache, ensuring a broader dataset for analysis. The broader context: Mars exploration in 2025. The Chayava Falls discovery comes at a pivotal time for Mars exploration. Perseverance continues to climb the Jezero Crater rim, exploring new geological layers, while its companion, the Ingenuity helicopter, has completed over 70 flights, scouting terrain for the rover. Meanwhile, other missions are advancing our understanding of the Red Planet. China's Tianwen-1 mission is mapping Mars's surface, and the ESA's ExoMars rover, set to launch in 2028, will drill deeper into the Martian subsurface to search for biosignatures. The discovery also coincides with growing commercial interest in Mars. SpaceX, led by Elon Musk, aims to send crewed missions to Mars by the 2030s, leveraging its Starship rocket. While SpaceX's focus is on colonization, discoveries like Chayava Falls highlight the scientific value of robotic exploration as a precursor to human missions. Looking ahead, the Chayava Falls sample is a milestone in humanity's quest to understand Mars and our place in the universe. It underscores the power of robotic exploration to uncover clues that could answer one of science's biggest questions. Are we alone? As Perseverance continues its journey, collecting more samples and climbing higher into Jezeros's ancient terrain, each discovery builds toward a future where Martian rocks are studied on Earth, potentially rewriting the story of life in the solar system. For now, the scientific community and the public await the next steps. The MSR mission's success will determine when and how we unlock the secrets of Chayava Falls. Until then, this rock, formed in a long-vanished Martian river, stands as a symbol of hope, curiosity, and the relentless pursuit of knowledge. As Dr. Farley put it, this is why we explore Mars, to find the unexpected and chase the possibility that life, even in its simplest form, might have once thrived there. For updates on Perseverance's progress, or the MSR mission, visit NASA's official Mars Exploration Program website or follow their social media channels. The journey to uncover Mars's secrets is far from over, and Chayava Falls may be just the beginning.